Well, tonight we're going to talk about the viaduct at Rio Como. So, guess you got two people entered the waiting room. You want to wait a few minutes, Rich?
That's just Ted. He just signed in twice.
Oh, okay. These screens are popping up on me too. So here's a version of a viaduct. Anybody remember where that was from? I bet you there's somebody in the audience that can answer
Burlington.
that.
Oh, Burlington.
It's where?
Burlington.
Burlington. Okay. And what did that viaduct do?
Went over the railroad.
Is that just north of Burlington where that was?
Yeah.
It's been replaced.
Yeah, with a concrete, well, whatever.
A concrete one.
Yeah.
Yeah.
But it looks just
but
like that.
That was in your layout. Yeah. But that was on your layout there in Anacortes.
Yeah, Steve built that, and he was still not quite done with it when we had to quit, but it was very similar to that.
There you go.
Old 99.
Here.
Yeah, the old 99 highway.
All right. Exactly. All right. Well, this is to get you. There's a lot of people coming in. This is to give you a view of what the Rio Como Railroad's all about. And, you know, I'm going to move ahead here. One slide. Come on. All right. So to start off with, the Rio Como is a railroad, a Colorado-based railroad, and it's being built as an ON30 layout in Freeland, Washington on Whidbey Island. And Jon Bentz is the owner. And management wanted to have a single lane viaduct constructed to allow vehicle traffic to cross over the Rio Como main line. The civil engineer said, well, isn't that a little more expensive than mainline, an at-grade mainline? And management says, you can do anything in make-believe. Now I got to see if I can go backwards here. Come on. Yeah. So just to tell you here, here's the layout again. And the Boyd and Son Lumber Company siding is where this is going to be happening. And if you can see my cursor here, it's going to start and cross over the main line, and then it's going to go around and behind the Boyd and Son Lumber Company. Now, John's made a couple of presentations to the clinic, but I'm sure he'll have more to say about this. There's a lot of elevation in this layout, I can tell you that. And I mean, there's places where it's going to be well above your head by the time you get your log cars unloaded and things like that. Okay, so now let's go ahead. So, as I indicated, the viaduct must be constructed behind the Boyd and Son Lumber Company parcel on land retained by the railroad. It must be sufficiently high to allow the largest Bachmann 460 locomotive to pass under the proposed King Post span. It requires a 90-degree horizontal curve and 4 vertical curves. So let's see the site here. So here's the Boyd and Sons Lumber Company, and this set of buildings was, oh my goodness, John, help me, who built these? John, can you hit the voice?
Yes. Steve
sorry.
Apollo built them.
There you go. Yeah, Steve DiPolo. He built these, then before he closed his store down, he decided he didn't need to keep them anymore because he's still an SN3 guy. And so I ended up with them, and Jon figured out a way to get the a site for the lumber company. Whoops, come on. Okay, so in plan view, we had to figure out how we were going to get around the corner, how we were going to have our trestle bents installed, what our spacing was going to be. We ended up on a nominal 12-foot spacing, which worked out pretty well. Still, getting around the corner looked to be kind of interesting, because I could only imagine if we were having a continuous grade through the corner, we would end up having funny bank corners, which might be kind of tough to build with sticks. So we'll show you how we got through that problem in just a second here. You can see the center line of the main line here, and goes under where we're going to have a king post truss. And here's a portal through this divider we have in the layout, because this is just kind of like one of those space portals where the train disappears or reappears from the staging yard that'll be on the left side of the divider. So here you can see it in a slightly different angle. And here's the portal that, here's the portal. We can see it's really messy there. This was very messy before Jon took this picture for me. But because we had so much stuff piled up there, we've been working on
Still there.
stuff. And there, I think there was a sawmill piled in here and a whole bunch of other things that Jon had to move to take this picture, because the one I had taken here a few weeks back wasn't adequate. All right. So I had to come up with a profile and figure out to what extent, you know, we would have transitioning, and how steep it would be, and to achieve the elevation we needed to get between the top of the rails and the bottom of the trestle structure itself. So you can see here, if I can keep my cursor going, we transitioned by having each segment between bents change grade by about 5 degrees, and 5%, excuse me. And then as we get to the corner where I was thinking we were going to have the problem with too much super elevation we create a flat spot coming around the corner. And then we proceed again with a transition through 2 more vertical curves going to 15%, and then back to 10, and then 5%. Eventually getting down to grade at the bottom of the viaduct. So structurally, these are give you a little idea about the bents and how we put them together. The king post section is a section right through the center, right above the center line of the main line. And you can see all the detailing there of what's going on. Notice we have a galvanized rod proposed here that would be a part of the king post, because that member is always under tension. And then there are top cords that meet at the top where the double 8x18 cap is.
It's up in here.
Oh, I see. It says
See over here.
Mhm.
Here's the rod.
Yeah.
Double cap here. This is showing kind of a cutaway face of the top cords. And
Alan went silent.
somebody muted me.
I did that. There was a bunch of background noise. Everybody needs to be on mute unless they're actually talking.
Yeah, I don't mind people interrupting occasionally, but yeah, that was kind of funny. Okay, so now here's a section that shows a little more detail of the members that I used. And I'm using what I call, real dimensioning. So if you're going to build an HO scale, you could just say, well, yeah, that's what he used. And then you just go find the appropriate scale lumber to do it. The footing is a 12 by 18 footing, which just for quick, since this is an O scale, that's a 1/4 inch by 3/8 inch footing. So those are pretty quick and easy. What more can I say? We've got a curb. We got an 8x8 curb we're going to put on there to help keep the traffic from taking out the handrails. Handrails, I didn't label the detail, but there's a 2x6 on the top, and then reinforced by a 2x4 underneath, and then there's another 2x4 rail on the facing. The posts are 4x6s. I didn't label that. And what else? The bracing and the decking, it's all 3x9 and or 1/16 inch by 3/16 inch basswood. Come on. All right, so we've got to build trestle bents. So I started out, and you can see here some members that are the 12 inch by 18 inches, I call them, footings. But I start out by setting up a jig so that I can drill pilot holes. The reason I wanted to do this in a jig is that the drill bit I could keep pretty well tuned on what I wanted to do and its location with a fence. And then I would come along, and over here in the middle of the picture, you see here my Brad Point bit that's has a special assembly. So essentially I got a drill stop locked in here, but I didn't want that to damage the wood. And so by putting these nylon bushings on each side, I could set the bushing here at the bottom so that the depth would not exceed half of that 1/4 inch, or about 1/8 of an inch. I could then take the dowels that were going to form my post, and I found a good source of dowels there right on Whidbey Island at Seabo's Hardware. They're pretty steady at 1/4 of an inch diameter. And I was able to tap those in. So I cut them a little wild, meaning they're a little longer than I needed for each particular post, and tapped them in. Now, most of them are just force fit. Tapped them in, straightened them up, made sure they were close. Then I took them over to my little bandsaw and set up the fence for the height of the trestle bent that I was building at the time. And I ran them through the bandsaw so that I had them all exactly the same length. And then from there, I could take the top cap and just glue it on to the trestle bent.
Hey, Al,
Yeah.
how did you keep the post from wobbling as you fed it through the bandsaw?
Yeah, it was just careful. That I was fortunate that the dowels were pretty tight in the holes. You could probably try to put a little glue in there, but you'd be fighting it. It wasn't like there was a lot of room for glue, and so far so good. But yeah, it was one of those things where you can see there's a slight difference in height here. Okay, so if you lay this footing on its side, And so what I did is I put a piece of gotta think of this, 1/16 inch board underneath the dowels. So they're laying on their side, similar to what you see in this picture here. But at the time, the top cap over here wasn't on it. And so I had essentially a 1/16 inch board underneath. And in fact, I think I used a little piece of plywood. And that way I could, and then put some pressure on it on each dowel as it went through the saw so that I could cut the first piece, move my finger back a little, push on the dowel for the second piece as it went against the fence going through the saw. So kind of just being careful, and then just also applying a little pressure so that it was, you were pushing not from the base of the bent, but from near where the saw blade was gonna go at the post. So then this third picture here, what it's depicting is I've now cut my bracing, the 3x9 bracing. I've glued them on, and now I'm drilling pilot holes from all my NBWs that are gonna go in there. So you can see you've got, in this case, 5 NBWs going into each brace. And so by the time you're done, you've already got 10 NBWs in each trestle bent. Are there any questions about this? All right. So now I've got all my trestle bents constructed, and I'm looking at how well I did with my grades. And you can see here I'm working with just some scrap pieces, seeing how everything looks. But I'm thinking, how am I going to hold this up and being able to put bracing on to keep this thing from falling over the whole time I'm working on it? Well, it's time to build a jig. So here on the left, you can see the plan view of where my trestle bents are going to be. And I had some really nice plywood with a nice smooth finish on it. And I actually have a joint right here, but I cut and made that piece so that it's the same width as the length of my footings. And then I came along and cut plywood spacers to go between each of the trestle bents such that they would not move around on top of this. Now, how do I lock it all down? So you can see here, this blown up version of the base. Here's the 3/4 inch plywood that formed the main base. And then here you see the 1/4 inch plywood that is the spacer. Again, that's the same dimension as my footing. And then I made these cleat strips to attach to each side, which was attached with brass screws, with the idea that now I can put these in place, hold down each of the footings, and not have them go anywhere. But then I had to be careful thinking about some of these spacers would have screws going vertically through them, and others would have to be loose so they could be removed, so I could eventually get this trestle out of its construction jig. So here you can see, especially over here on the right, you can see the spacers. Here's a couple of them with screws in them. You can barely see the plywood, the 3/4 plywood, because it's got a different grain under here. But then you can see the dimensioning, the cleat that goes around each of the footings and holds them in place. Another picture of that on the left. And here we have everything ready to go. and it holds everything in place really well. You notice here in the center, you can see these screws here and these screws here. Well, because I can pop this piece of plywood out, that's not going to be a problem. I'll still be able to pull this viaduct out of there. And then each of these other pieces of plywood in here like this is tapered, so this one will pop out easy. The rest of these are loose enough that once I remove the corner molding here, they'll all pop out just fine. Okay, now we got to put the bracing on. And I thought I should probably figure out a way to do this so that I could have gravity as my friend. And so using the fence on my table saw, I essentially elevated the jig so that if I wanted to, put bracing on this side, for example, or in this case, I think I was working on the inside corners here. As you can see, here's another view of it. You can see how I can install a brace, let gravity do its thing to hold it in place. And then I could also invert it and take it over to another vise and then work on the other side the same way. So that made life a little easier. And it's still a long process putting all these on. So now we got to get the king post done. And I said to myself, how am I going to make all my king posts so they're all exactly the same size? And I realized that if I put it in a jig, that if I cut along the line here and along the line here every time, they would all be the same size. Well, the magic of that is this has to be a perfectly square board, which is it's not the safest thing to be doing with your 10-inch cabinet saw, but I pulled it off. But you can make this safer by installing it either in a sliding top, or you could have a longer board that you could install this on such that you could rotate it on that board and then still have it more safely piloted through your table saw without it binding on you. So we start out, the reason this is over here on the right, the reason that the stringer is extended is this is the portion that extends out beyond the end of the trestle, the viaduct, right at the face of the layout. And so you can see here 2 top chords installed in place. Did I hear a question coming?
Yeah, you did. So that the picture on the left is a jig you ran through the table saw to make the perfect timbers.
Exactly.
Okay.
And I was very careful. You see, the table saw blade is bigger than this board. That's why I was mentioning the safety aspects of doing this. You could probably do it even more safely in one of those mini band saws. But you can see if it's the same dimension, all you got to do is rotate this 90 degrees to run it through the other path. And the only trick you got to worry about right in here is just make sure this is tight enough so that the piece that you're trying to cut doesn't move on you between cuts. Does that answer your question?
Oh yeah. I was just curious if you ran that through your table saw as opposed to cutting those pieces by hand in the jig, but you ran it through the table saw.
Yeah.
Okay.
It made sure all my joints were square, and and each piece was the same size. Okay, so now as we progress through, here are two of our posts installed. We put some spacers in because we needed a 2-inch space in between in order to get the tension rod installed. And then we installed the rest of the handrails that are going on this portion of it. And you can see this piece here goes from here to here. And then these are just pieces to tie it together. So this and this are not the same. Now this is on top of it. And it just gave it some structural tie-in. And the 2x6 on top, there's a hole drilled right through the center of the 2x6 here so that the tension rod could go through that. And so I installed the handrail, and then I used my pin vise with a drill bit, and I was able to drill out the hole to put this through there. Now we need some gusset plates. So these gusset plates, the small ones here on the left, I got a little jig here so I can drill these out, and you can see most of them ended up looking pretty good. You can see this guy's a little off here, but by just flipping it over in all directions, I could get all these holes drilled. And then we have, so these are 1/4 of an inch by 3/16 of an inch. And these are 1/4 of an inch by 1/2 an inch. And you can see that there's an offset. There's an offset here, and you'll see what that's about a little later. Okay, so now we put the second top chord on and the second stringer on. And then we've got some spacers here in order to tie in to the next stringers that are going to tie into the structure later. Here you can see then the gusset plates, and here you can see the one where they had the diagonal screw or bolt holes right here. And then we have the smaller gusset plate up here and just plain bolt heads on the other side. We didn't need to have the same structure as we did here because this is being pulled down, held together. Here you want to prevent sliding, so an extra bolt on each piece is appropriate. So here you can see we've got one of the A-frame sections done there. You can see how I've used connecting pieces here. This is just to help hold it together. Typically that wouldn't have been done for most of the structures. You might be able to see over here, right here, there's a pin actually going through this one into this one. So in case, because I'm gluing these on and these are only 1/4 inch wide, in some cases I'm putting pins in, and or in this case here, you can see the tops of some number 2 screws that I set into the top of the stringers so I could screw the stringers to the bents just to help hold everything in place. Progressing along, slowly getting all the stringers in place. Here you kind of see how, and I want you to know that the design of this and how this all went together around here was in flux the entire time until I actually did it. It wasn't something that I pre-designed, but I came up with what looks like a plausible way. The spacing between the stringers here is the same as the spacing on the other segments. And I was able to find support on the on the top top cap of the Bents, and I put blocking in, as you can see here, just to help hold things together. More gluing surface helps hold things together. Here you can see better the recessed screws that were used to attach some of these to the tops. And then here, over here, you can see a pin that's been driven using a piece of brass rod. Oh, but we got to make posts. Now, you know, it seemed to me like I wasn't going to use a pin vise on all these. So I set up a jig and I drilled pilot holes for all of my NBWs. I can't even say it right. And I used a bit of Aleene's glue in each hole. It's just tacky enough to hold things in place so they won't fall out. And then I trimmed using a flush trim cutter on the back side because they were sticking through a little bit. So it's flush. And then I used a very small sanding block to make sure there weren't any protrusions from the remainder of the plastic coming through the back side of these posts. So here we have it. We're all ready to go. We start installing the posts. So one of the things I thought would be important, first of all, I wanted a 4-foot spacing. You can see these lines drawn on the sides of the stringers here. But I couldn't, because I was putting a gusset plate at these joints, I couldn't put a post over the gusset plate. So essentially, I've got 4-foot spacings and 2-foot offset from the joints in the stringers. But I thought, you know, we don't want to make these perpendicular to the angle of the stringer. We wanted to make them perpendicular. That's why the square is here. So you can see here, while this is using gravity a little bit, again, I've clamped on this little piece of plywood. That makes sure as I set the stringer down, which is hiding underneath this clamp, that I get the bottom of the post lined up perfectly with the bottom of the stringer. And that helped when it came time to put the handrails on. And you can see here just some of the effort. So again, using that same technique, the green clamp here is holding a tool, essentially holding this board in so that when I set this post in place, it's bottomed out where it should be before I clamp it in place. Now we've got to put spikes in our boards. So for a good chunk of the viaduct, the width is 14 feet. So by creating a template here on paper, you know, I can take each of these boards and I can use my owl and I can punch my spike holes on the boards. And then as you can see here, I started kind of in the center here and I worked my way out in both directions. But you can see this group ended up being one of the darker sections of spikes that I got in the whole model. It varied depending on what day of the week it was I was working on it. The one thing I'll note is that you can see the taper of this owl here is pretty slender. And possibly by taking a finish nail, and which has a steeper angle to it, and file it a little bit so it's sort of halfway in between what a standard nail tip is and what this awl is. You might get a more consistent, because if you're not careful with especially 1/16 inch thick wood, you'll occasionally split the wood if you get too aggressive as you're putting the spike holes in. Is one of those things that you could, depends on, you're trying to do this quickly but trying to do it carefully as well. So getting around the corners, I couldn't use that template. I had to essentially work in place. So as you can see here, measure, cut, add bolt holes, stain, glue, repeat. That's exactly what I'm doing. And so I would have all of these cut in place, and then I would take and use my awl, and I would be able to see underneath where each of the stringers was, so that the holes would be in the right place. Handrails. You can see I almost ran out of clamps. I think I was digging to the bottom of the barrel here to put these on, but this section here is continuous, and because you can see there's a sag here, and then there's a crown in it, and so I had to essentially lay out both of the handrails here and in a couple other places so that I could glue the 2x6 to the 2x4 in the profile that it was going to sit on. And then that's why I'm gluing this all in place at one time.
So you said the handrails is one continuous piece of wood and you just bent it around the slope changes?
Yeah, but I pre-bent it before I went to install it. Essentially, I used some foam core, and I taped the profile, and it was based on actual measurements. So I took my as-built measurements of the post from a baseline, drew it up on CAD, printed it out, stuck it down, put some wax paper over the top of that, and then use sewing pins to flex the handrails in the proper profile, at the same time gluing them at a 90-degree angle to each other. So here's a close-up, a little brighter close-up of the tension rod. So a lot of the trestles you see that have tension rods in them, they're not functional. The channel sections come with molded fake bolt heads on them already, and all you've got to do is put a tension rod in there. In this case, these tension rods are indeed in tension. So using 034 brass, I took 0090 a die, and with a lot of effort, I was able to get both ends of the tension rods threaded. I think there's something about hardened brass rod that it just doesn't work as well as you would think it should. And then I also had to take the 0090 nuts and ream them out a bit using a tap, using a tap, and finally got them to go enough so that I could thread them on. And then the tricky part was actually, okay, how am I going to actually get these things tightened up? So a barrel type wrench was used, and because of the slight taper in the barrel wrench, I had to actually put one nut inside over the top of the nut that I was actually trying to secure in order to thread the bottom nut on. So here's a final view of the entire trestle viaduct. Little expanded view here. The gusset plates you can see there. That was kind of fun doing those. Going around the flat corner here. You can see I didn't use gusset plates here in the middle of the curve because these members are actually tapered joints. So these are tapered so that they can then go be mounted flush and bolted flush to the other stringers here. And coming down to the landing. As you can also see here, we didn't have any gusset plates because these were continuous pieces of stringer. Oh, remember, you know what, when the discussion came up about whether or not we could afford a viaduct? Well, as I was getting finished building the viaduct, the management came and said, oh, we need to put an at-grade crossing over here on the lower right of the layout. That was almost as hard to build because there's about as many nail holes in that as.
Here's a little secret. I like to torture him.
We have our discussions. All right. So those of you who are numbers guys, just to give you some rough ideas of the numbers of pieces that actually went into this thing. I've put the lengths in feet just for fun. And these are just estimates based on my being able to either count and or average lengths of members throughout the model. I want you to note there's 78 dozen NBWs in this. And I've given you the Tichy number there. And 1,700 faux spikes. And when I call my specialty tools include a 12-inch chop saw, 10-inch cabinet saw, 12.5-inch planer. Then I have the Microlux variable speed drill press and the bandsaw, and then the O90 tap and die. Any other questions?
Yeah. What did you use the planer for?
Oh, remember we took those, excuse me, 3/16 down to make them like 8 inches instead of 9-inch thick stringers.
Okay.
So we went 8 by 18. So essentially went to the store, bought a 3/16 by 3/8 inch piece of basswood, and then we just zinged it through the planer.
Oh.
Just shrink it down a little bit.
Then I noticed also the cap pieces on the bents.
Yeah.
You tapered them. You angled them.
No.
Yeah, you did, because I saw it in your photos.
Well, you mean
to match the gradient.
Oh, to match the gradient, yes. In most cases, they had to be tapered on the lower side, the steeper side.
Yeah.
Yeah, that's correct. I was thinking of the question in another one.
Nope. Okay. Well, management very much appreciates the engineer's efforts.
Thank you, John.
Which approach overachievement.
Taper the planks around the curves.
Okay, here, let's see if I can find one for you. You remember where that showed up best, John?
Well, it was earlier on when you were showing it, the earlier construction.
Yeah. So
Yeah,
for
here.
example, here. Yeah. So the cross section of the top cap here, I used a plane to kind of shape half of the top of this so that the idea was to get it so that the tops of the stringers would match up. And so you had to kind of think of that. And in some cases, I actually cut the stringers at an angle to fit, so they'd fit close together. Does that?
Yeah.
Okay. Yeah, I don't think there's any other pictures that show that much better.
So did you just eyeball that, or was that a deliberate angle measurement that you did?
It was an eyeball thing.
Okay.
You know, set up the stringer, kind of look at it and say, okay, how much do I have to take off? I used a little tiny shoulder plane to do that.
That little brass one?
Yeah.
Yeah.
Actually, I used the big one and I clamped it into the wood vise.
Oh,
And then I'd just sit there and I'd kind of rotate with my hands the timber piece and then slide it through. Of course, you had to be careful because if you overdid it, and then you'd have a whole trestle bent that you had to throw away, which fortunately I didn't have to.
yeah.
Any other questions there?
Oh yeah. Have you taken it out of the jig yet?
No. I'm not going to subject it to our layout room yet. So it's safely tied into this jig so that, plus it's easier to carry. You know, I've taken it to several of our clinics as this thing was going along, and some of you saw this along the way.
And we're really not ready for it yet. Things are a little wild and woolly still, so.
I've got a place that it's secure.
I'm sure you do.
How long did
And
the
your gun
erection?
safe?
Essentially, I started in October of 2019, and I finished up just before we went into lockdown.
Yeah.
So I got a question. What drawing application did you use for your CAD drawing?
I use AutoCAD. The humor about this is, though, my computer was 20 years old and it fried on me about 4 months ago. I had to reconstruct all these drawings from the as-built. But yeah, I use AutoCAD.
Did you talk about tapering the planks, the decking planks and the curve?
Here, everything was pretty plain. Just right in here, you can see where my cursor is. That was probably the worst case where I had warping as the planks went across. There were a couple of cases where I had to actually cut the plank, and then because the warp was too weird. But most of it ended up so that the planks could hit the pattern like I had here. So let me go back to that. Wait a minute. Yeah, here. So right in here, or no, it was right in here. I had some issues with, and that's what this is doing. I have a plank that is slightly sprung here. So as I glued it in place, I had to get extra help from some clamps to hold it in place. Whereas ones down here where everything was flat, all I had to do is hold it in place for a few minutes and then we were in good shape.
I have a question, Alan.
Yeah.
Where'd you get those clamps?
These guys?
Yeah.
I think I ended up buying it at one of the train shows. I think they're available online.
Oh, okay.
the
I've
long
never
ones.
seen them before, so.
Yeah, I think
could-
they're
Yeah,
they're readily available, just like the short ones. It's this, I think it's the
Mhm.
same manufacturer.
okay, thanks.
So yeah, I'm sure I speak for everybody, but that was a great presentation. Some very precise and well-engineered work there. I mean, you basically built that out of your brain, which is got a vast storehouse of knowledge there on how to build stuff like that. So it was very, very impressive.
Thank you. Yeah, I think the key thing is, I grew up the son of an architect and I'm a civil engineer. And part of building things is looking at all the infrastructure we've got out there and just see how it's put together and then think about how can you do the same thing in your own model building.